Hello and welcome. My name is Jesse Cook. This is for class ISA4220. Today we'll be talking a little bit about databases and the hardening practices for securing those databases. To open up this presentation, I'd like to talk about what is a database. A database is any organized collection of data. But more specifically, a database is an electronic system that will actually allow data to be accessed, manipulated, and updated. It's usually accessed from a computer system. They are also stored in a central location, and then users are able to access the database through a remote system, and there they can store and manipulate data. Databases are found all around us in our everyday lives. A few examples of this are telephone directories. Most businesses use databases to control and manage their billing. All social media is just examples of large databases, and they're organized different types of data. They're all usually ran by a management service, other known as a DBMS, Database Management Service. This service allows users to easily view and modify their data. It is also used to organize the data by different traits or qualities that data has in common. We'll talk a little bit more about this in the further types of data. It also allows for data uniformity, which is when data is live across the entire database, which means whenever someone makes an edit in one place, it is synced up across all systems that may be viewing that data. It also has built-in capabilities that restrict access to the data, which means that anyone from the public or who is also on the network would not be able to access that data unless they have a login that has been credentiated to them. It also provides data redundancy, which is when the service actually backs up the data either to an online cloud or a different server. And that way, if the data is lost or corrupted, then it has a backup and no data will be lost. There are many different types and models of databases that exist out there. But there are two main types or ecosystems, if you will, that these models and types all break down under. Those main two types are SQL databases and non-SQL databases. SQL databases are much more widely known and popular than the non-SQL databases. SQL databases store data according to a scheme that allows data to be displayed as tables with both rows and columns. These tables have keys associated with them, which are used to identify specific columns or rows of a table, and they also facilitate faster access and organization of certain data. They also mostly have the capability of data integrity, which is part of its software that uses a number of constraints that ensure that the data within the tables is both reliable and accurate. The most popular known relational databases are Oracle, MySQL, and PostgreSQL. Now let's talk a little bit about non-SQL or non-relational databases. Non-SQL databases can take a variety of forms. This is mostly because they are grouped together based on just the fact that they are non-SQL databases. But the main difference between non-SQL and SQL databases is that in SQL databases, the scheme will rigidly define how data can be inserted into the database, and non-SQL databases do not place restraints on how data is added or not added. So it allows for unstructured and semi-structured data to be stored and manipulated, as well as the regular structured data. The most commonly known forms of non-SQL databases are key value stores, graph databases, and search engines. Now that we know the different types of databases, we can look at the different database models. A database model shows the logical structure of a database, which is essentially the relationships and constraints that determine how data can be stored. Having a database model that is on the list of database models is not a requirement, but most databases are built with a database model in mind. The main different types of database models are relational, which is the most commonly used and known model of all. The relational model sorts data into tables, also known as relations. Consists of columns and rows of data. Each column in a relational model lists an attribute of the entity in question. The most different or particular attribute is usually chosen as a primary key, and the data will be organized based on that. The second most differentiated column will be its foreign key. There's also a hierarchical model, which organizes data into a tree-like structure. Each piece of data is sorted into different categories so that each record has multiple parent groups that it is a part of, but it is its own individual record. There's also the network model, which builds onto the hierarchical model, and it further goes into depth into the many relationships that can be leaked between records. So records can have multiple parent records, and there are multiple relationships that can be between each set of data. Next is object-oriented database models, which organize data as if it was a collection of objects. These objects are often not very relatable to each other, so each record is described by certain features and methods of that data. Lastly is an entity relational database. This is for much more complicated databases. This database essentially relates data to relationships with real-world entities. Each data point is organized by certain attributes, and then the items with those attributes are organized together to make a domain. For this class, the database management service that we will be using is called Postgres SQL. It is an open source software, and it uses an object relational database model. It is known to be extremely versatile in that it supports many different types of data types, and it also supports both small databases and very large databases. The main features of Postgres are MVCC, or its multi-version concurrency control. This is a part of the software that allows multiple snapshots of the database that can be edited without locking others out. And it also keeps the integrity of the data while doing that. Another feature is asynchronous replication and point-in-time recovery, which is the database saves and backs up at certain points in time, and if data is lost or corrupted, then you can just refresh the database back to that point in time. Now let's discuss some hardening recommendations that we can make for someone who's installing Postgres on a Linux server. Uh, First recommendation would be to keep whatever database management service, or in our case it would be Postgres, up to date on the most current software. Next would be to set a client authentication control, which is actually already built into Postgres. We just need to go into the configure files and change the configuration. And here you can put a list of clients and their logins, and whenever they make connection to the server, they would be required to log in and authenticate themselves. Next would be to set an IP address control list. This is also built into Postgres, but just needs a little work in the configure files. You can go into the configure files and set a list of IPs that the server should allow to connect to the database. Next recommendation would be to implement user roles that allow the least privilege. This is the process of creating different roles within the database, such as a manager of the database, a read-only user role, and then maybe a moderate control role. And you can assign these to the users. That way users have the least amount of privilege that is necessary for them to use the actual database. The next recommendation would be to implement secure socket layer connections and data encryption. This is not built into Postgres, but it can be configured to use this. This is an authentication method between a web server and your browser, and it ensures that all data that is passed between the two remain private and encrypted. The last recommendation that we would make is to enable logging on your database. This will ensure that all changes that are made within the database can be reviewed and monitored by the management users of the database. That brings us to the end of my presentation. Thank you so much for watching. Here are my sources.